so yesterday we went over volume of prisms and cylinders. Okay, our next three-dimensional shapes here are going to be pyramids and cones, just like we did with surface area. So now we're finding the volume of pyramids and cones. Starting with a pyramid. The volume of a pyramid is 1/3 capital B times H. Okay, a pyramid is 1/3 of a prism. Okay, so we have 1/3 B times H, where B is what? What is B going to be? Okay, it is the area of the base, or the base area. Okay, your base can be a rectangle like these two over here. It could be a hexagon. It could be a triangle. Okay, so that base shape in a pyramid can be multiple different types of two-dimensional figures. Okay, and then H is the height of the pyramid. Now, before, when we were doing surface area of pyramids, we needed the slant height. For volume, you don't need that slant height. Okay, we need the height, which is the perpendicular distance from the vertex to the base. Okay, it has to be that perpendicular distance. So in these ones, we're not looking for the slant height, just the height of that pyramid. So we're going to do a couple examples here. So we want to find the volume of each pyramid. In number 1, first thing I do is locate the base, right? So our base shape is a rectangle. Okay, and I need to find capital B and I need to find H. So to find this capital B value, that's the area of the base. Since our base shape is a rectangle, we need to take base times height of that rectangle. Okay, the base of that rectangle would be 9.5. And the height of that rectangle would be what? 8. Okay, so we're just finding the area of that rectangle. So if I multiply 9.5 times 8, I do get 76. Sit down. It's not going to do anything. Sit down. So capital B is 76 centimeters squared. Okay, I also need my H value, or the height of that pyramid. So from the vertex, perpendicular to that base, okay, that distance is going to be 9 centimeters. So now that I have B and H, I can find the volume. Okay, to find the volume, we're taking 1/3 times our capital B value is 76 times H is 9. Okay, so multiply together 76 and 9 and then divide it by 3, or you can type in 1/3 times 76 times 9 if you'd like, but you should end up with 228 centimeters cubed. Okay, and again, our volume is in cubic units. Okay, questions on that first one? All right, do number 2. Do number 2. Locate your base shape, find the area of that base shape, and then the height of the pyramid.
I'm going to get one. It's in my bag. I don't know. Some things will go up.
That's actually good. Because it needs at a 90 degree at the bottom.
All right, number 2, what is the base shape? What's the base in the shape of? A triangle. Good. Okay, so here's my base shape. So to find capital B then, we should use base times height divided by 2, since that's the area of a triangle. Okay, the base of that triangle is 15, and the height of that triangle is 6. And we'll divide that by 2. Okay, and you should get that base area to be 45. Okay, so capital B is 45 feet squared. Okay, then our height, again, is the perpendicular distance from the vertex to the base. Okay, that is already drawn in for us. It is 14 feet. Okay, so now that I have B and H, I can find the volume. Okay, our formula is 1/3 capital B times H. So we have 1/3 times 45 times 14. And you should have gotten 210 feet cubed. Okay, questions on number 2. All right. Then, since the volume of a pyramid is 1/3 the volume of the prism with the same base and height, the volume of a cone must be 1/3 the volume of a cylinder with the same base and height. Okay, so here we have a pyramid with a hexagon base. Okay, it's inside this prism. Okay, that pyramid is 1/3 the volume of that prism. So that means if I were to have a cylinder, I could create a cone within that cylinder, and it's going to also be 1/3 that volume. So since the volume of a cylinder is just B times H, our formula for volume of a cone is 1/3 B times H, just like it is for a pyramid. Okay, and again, we have a capital B value, that is the area of the base. Okay, since our base shape is always a circle in a cone, we have to use pi r squared to find that area. Okay, and then H is the height of the cone. Okay, and again, when we did surface area of cones, you needed the slant height. Now for volume, you do need the actual height of the cone. So that is from the vertex point and perpendicular to the base. So in some of these, it will be a right cone where it hits that base at that center point. Other times, it will be on the outside, or it could hit at a certain part of your radius. Okay, as long as it's from the vertex and perpendicular to that base, that is the height of that cone. Okay, questions before we do some examples? All right, then on the back, numbers 3 and 4, we want to find the volume of each cone. It does say to keep pi in your answer. We don't have to do that. But if I do ask you to keep pi in your answer, do you know what that means?
Yeah, just don't multiply by pi.
Just don't multiply pi into it, okay? That means your final answer would have the symbol pi in it. Okay, so if I ask for the exact answer, you have to keep pi in it. Okay, we're going to be rounding anyways when we're dividing, so we're just going to round with pi in it as well. So number 3 here, first thing I want to do, locate my base shape. It is a circle since this is a cone. Next I want to find capital B. Okay, and this one to find capital B, I do have to use pi r squared. Okay, and our radius is 3.2. Okay, so we have 3.2 squared times pi. Which is 32.2. If I multiply pi in, if I didn't, it would be like 10.24 pi, I think it was. So capital B is 32.2 meters squared. Okay, then we need the height of this cone. So from the vertex, perpendicular to the base right here, that is 5.8 meters. Okay, so now that I have B and H, I can find the volume. Okay, our volume is 1/3 capital B times H. Okay, so multiplying 32.2 times 5.8 and dividing by 3. Okay, and you will get about 62.3 meters cubed. Okay, questions on number 3. All right, then looking at number 4, in this one, we are given this length right here. Okay, that length from the vertex to the base and perpendicular is the height, right? So we already know what the height is. It's 11 inches. However, to find capital B, I need to know what this radius is right here. Okay, because I need to use the radius to find the area. If I look at my cone, I can see this right triangle formed. Okay, so I have a right triangle formed. How can I find R? I cannot use the Pythagorean theorem. Alexis? You can use tangent. Okay, so we can use SOHCAHTOA to find that R value. Okay, so I'm going to use SOHCAHTOA. Okay, I have an angle of 58 degrees right here. Okay, from this angle, if I look to the side I'm given a number for, that's considered the opposite side. What is my R side considered? My radius side. It is adjacent. Okay, so I have opposite and adjacent. Okay, that's tangent. So I would take tangent of the angle I went from, so that's tangent of 58, is equal to the opposite side, that's 11, over the adjacent side is R. Okay, so from here, I just need to solve for R. Now, when I'm solving for R in this case, we always multiply by whatever's in the denominator to cancel it out. So I would end up with R times the tangent of 58 is equal to 11. Okay, next, what do I do to get R by itself? Divide by tangent of 58. Okay, so it cancels out on the left. I can plug this into my calculator. So 11 divided by tan 58 to get a radius of about 6.9. Okay, so now that I have the radius, I can find capital B. Okay, using pi r squared. So we have pi times our radius, which we just found to be 6.9 squared. Okay, so 6.9 squared times pi is 149.6. Okay, so capital B, 149.6, and that would be in inches squared. Okay, now I can find the volume by taking 1/3 capital B, 149.6 times H, 11. Oops, 149.6 times 11. Okay, and you get about 548.5 inches cubed. Okay, questions on example 4? Okay, you do have a problem on your assignment where you have to use SOHCAHTOA. Okay, I think you have to solve for either the height or the radius. Okay, so please make sure you are remembering how to do SOHCAHTOA here. Okay, please remember that. All right, so moving on. Number 5. At the top of the Washington Monument in Washington, D.C. is a small square pyramid. Okay, so top of the Washington Monument, you have this small square pyramid here, meaning that base is a square. Okay, it's called a pyramidion. This pyramid has a height of 55.5 feet with base edges of about 34.5 feet. Okay, we want to find the volume of that pyramidion. Now, in my problem here, it said we had a height of 55.5 feet. Okay, I need that height to find the volume. So my height is 55.5 feet. Now I also need the area of a base. Since it is a square pyramid, that means my base is a square. Okay, and it has base edges of about 34.5 feet. Okay, so that means each side of this square is 34.5. Okay, so how can I find capital B then? I can multiply base times height, so 34.5 times 34.5. Okay, so that will be 1,190.25. Okay, so our base area is 1,190.25 feet squared. Okay, and then I can find the volume using my volume formula of 1/3 capital B times H. Okay, so multiply, then divide by 3. Okay, and you will get 22,019. And it did say round to the nearest tenth, so 0.6. You do get 0.625, but rounding to the nearest tenth here, I get 0.6. Okay, questions on number 5. All right, then I want you to do number 6. Last problem. Read through it, draw a picture, find the volume of that conical building.
No. There should be one.
All right, so looking at number 6, conical building means it's in the shape of a cone. Okay. The height of this building is 100 feet, so that's what I labeled here. And you were given the area of the base is about 15,400 square feet. Okay, that is your capital B value. Okay, you don't have to find the capital B value. They already gave you the area of the base. Okay, so capital B would be 15,400 feet squared. The height was also given to you. I labeled that. That was 100 feet. So I can find the volume, okay, needed for the heating and cooling systems by taking 1/3 capital B times H. So 15,400 times 100 divided by 3. Okay, you can write it as 513,333.3 feet cubed. Or if you have a repeating 3, it's 1/3. Okay, so you could also write it as 513,333 and 1/3 feet cubed. Okay, questions on number 6? All right, then please work on your assignment.